Hello, my name is Matt Rogers, and this is BIDA640. Today I'm going to be discussing chapter 11.1 through 11.6, which is sentiment analysis and opinion mining. So, introduction: sentiment analysis or opinion mining is a computational study of opinion, sentiment, appraisal, evaluation, and emotion. So why is it important? Opinions are key influencers of our behaviors. We use others' opinions to make decisions for ourselves. What products we're going to buy, which movies we're going to see, which music we're going to listen to. Our beliefs and perceptions of reality are conditioned on how others see the world. Whenever we need to make a decision, we often seek out the opinions from others. With the rise of social media, there's been a rise of opinion data. The rise of artificial intelligence and chatbots, emotion and sentiment are key to human communication. So sentiment, as defined by Merriam-Webster in the dictionary, is an attitude, thought, or judgment prompted by feeling. A sentiment is more of a feeling. For example, I am concerned about the current state of the economy. Being concerned is a sentiment. An opinion is a view, judgment, or appraisal formed in the mind about a particular matter. It's a concrete view of a person about something. I think the economy is not doing well. So sentiment analysis is a fascinating problem. It's intellectually challenging and it has many applications. A popular research area in natural language processing and data mining. It's spread from computer science to management and social sciences. There's a large number of companies in the space globally. In the US alone, there's over 300 companies. Touches every aspect of natural language processing. However, it's also confined, and it's a simple semantic analysis problem, a major technology from NLP, but it is difficult. Okay, so let's first talk about the sentiment analysis problem. So there's two main types of opinions. There are regular opinions and comparative opinions. Regular opinions are sentiment or opinion expressions on some target entities. So for example, a direct opinion would be a touchscreen is really cool, and an indirect opinion is going to be after taking the drug, my pain was gone. There's also comparative opinions, comparison of more than one entity. The example they give here is the iPhone is better than the BlackBerry. We focus on regular opinions first. We just call them opinions. So they first describe an opinion as a quadruple, which is broken down into a target, a sentiment, a holder, and a time. And you can read here that in their blog that they got up here, I bought an iPhone yesterday. It is such a nice phone. The touchscreen is really cool. The voice quality is great too. It is much better than my BlackBerry. However, my mom was mad with me as I didn't tell her before I bought the phone. She thought the phone was too expensive. So the target can be the iPhone. Sentiment is nice, which is positive. And the holder would be the user here, ABC123, and the time, May 1st, 2008. So this definition is concise, but it's not easy to use. And targets can be complex. For example, I bought an iPhone. The voice quality is amazing. So is voice quality the target? Well, not quite. So a more practical definition is an opinion as a quintuple, which breaks it down into entity, aspect, sentiment, holder, and time. So the entity is a target entity, or the object. The aspect is the aspect or feature of the entity. Sentiment can be positive, negative, or neutral. a rating or an emotion. The holder is the opinion holder, and the time is the time when the opinion was expressed. So we'll look at aspect-based sentiment analysis, and we can look at that first blog in terms of quintuples. And if you notice here, it says in quintuples, it gives the entity as the iPhone, and because in the first sentence here, it is such a nice phone. Talking about the phone, not exactly an aspect. And for that, they just use the term general here. It's nice, so it's of course positive. And then the holder is ABC123, and then the time 5/1/2008. And then we go down to the next opinion, and it talks about the iPhone as the entity. The touch screen is going to be the aspect in this case, and it's really cool. So of course that's positive. ABC123 is the user again, and of course 5/1/2008 is going to be the time. We'll be discussing the comparative opinions later. So with an opinion summary, when you have a lot of opinions, a summary is going to be necessary. And this isn't a traditional text summary from long to short. It's going to be a text summarization defined operationally based on algorithms that perform the task. So an opinion summary can be defined precisely and not necessarily dependent on how the summary is generated. It also needs to be quantitative. A 60% positive is very different from 90% positive. The main form of opinion summary is going to be aspect-based opinion summary. So here we've got an opinion summary for one phone, and then underneath it we have an opinion summary for two phones. The one on top is, actually they're both divided into 4 different aspects. You've got voice, screen, battery, size, and weight. So you'll notice that for the aspect touchscreen, there's 212 positive sentiments for it, and if you look listed underneath it is those actual opinions. The touchscreen was really cool, and the touchscreen was so amazing to use and can do amazing things. It was much more positive than it was negative. It shows there that it had 6 negative statements or opinions there. So here's a couple of examples of aspect-based opinion summary. One's on Google, and looks like a Sony camera, and its rating. And then kind of behind there underneath is one from Bing. And of course, here's another one for summarization of 2 TVs, where it lists both the pros and cons for each ones. And sure you'd be able to click on those to read what the customers were able to say. So it's not just one problem with figuring out what the entity, aspect, sentiment, holder, and the time is. There are more problems because the entity and aspect and these things aren't necessarily referred to with the same words. You may have an entity name that is given by the user, but there's also an entity expression that is the actual word or phrase that appears in the text, and the same thing goes with the aspect. So we have synonym grouping, which here it shows that voice can be synonymous with sound quality. Also co-reference resolution. So then we have a reason for opinion or sentiment, and the definition here is a reason for an opinion is a justification or explanation of the opinion. And there are two main cases. First one, for example, is I hate this car as it eats too much gas. It's negative about the entity due to a bad aspect. This can be identified by negative aspects. So the car uses too much gas. That's a negative aspect. In the second example, it says the car is too small, and it's negative about an aspect because of a reason. It can be identified by aspect-specific sentiment. There's also a qualifier of an opinion. A qualifier limits or modifies the meaning of the opinion. The example it gives here is the car is too small for a tall person. So it qualifies the car as being too small for someone who is too tall, or the picture quality of night shots is bad. And also, you also got to remember that not every opinion comes with an explicit reason or an explicit qualifier. For example, a sentence with no reason and no qualifier is this car is bad. So there's two closely related concepts. There's subjectivity and emotion. Then you have sentence subjectivity. It gives differences between an objective sentence and a subjective sentence. Objective sentence presents factual information, and the subjective sentence expresses some personal feelings, views, emotions, or beliefs. An emotion is defined as a mental state that arises spontaneously rather than through conscious effort, and is often accompanied by physiological changes. So subjective expressions come in many forms. There are examples, allegations, desires, beliefs, suspicions, speculations. Many subjective sentences also don't have to contain an opinion, positive or negative. The example they give here is, I think he went home after the class. Definition, subjective opinion is a regular or comparative opinion given in a subjective statement. The examples I give: Coke tastes great. I think Google's profits will go up next month. This camera is a masterpiece. We are seriously concerned about this new policy. And they have a comparison one on the bottom there. Coke tastes better than Pepsi. So most opinion sentences are subjective, but objective sentences can imply opinions too. Don't necessarily have to be subjective. They express desirable or undesirable facts. So if you had the statement, the machine stopped working in the second day, that's obviously a negative thing, since it's only worked for a little over a day. Or we bought the mattress yesterday and a body impression has formed. Well, nobody wants a mattress that won't hold its form. Or after taking the drug, there's no more pain. Such sentences are kind of difficult to handle. All right, so there's three closely related and confusing terms. And here are the dictionary definitions for them. There's affect, emotion, and mood. Definition for affect is a feeling or emotion, especially as manifested by facial expressions or body language. Emotion is a mental state that arises spontaneously rather than through conscious effort, and is often accompanied by physiological changes. Mood is a state of mind or emotion, and a feeling is an affective state of consciousness, for example, resulting from emotions, sentiments, or desires. The psychology definition of affect is a neurophysiological state consciously accessible as the simplest raw feeling. Emotion is the indicator of affect owing to cognitive processing. Emotion is a compound, not primitive feeling, concerned with an object such as a person, an event, a thing, or a topic. And mood is a feeling or affective state that typically lasts longer than emotion and tends to be more unfocused and diffused. So there are no agreed upon set of basic emotions of people. However, Parrott says that people have 6 basic emotions. There's love, joy, surprise, anger, sadness, and fear. And although related, emotions and opinions are not equivalent. An opinion is a rational view on something. It's polar, positive, or negative. You cannot say I like. An emotion focuses on an inner feeling. Can say I am angry, or there's sadness in her eyes. Here we have some examples of the 6 emotions and some words that can be used in place of those. Cause for emotion. Emotions have causes as emotions are usually caused by some internal or external events. Cause, not reason, because an emotion is not an effect produced by a cause, usually an event, rather than a justification or explanation in support of an opinion. After hearing of his brother's death, he burst into tears. So an emotion can be defined as a quintuple entity, aspect, emotion type, feeler, time. The example they give here is, I am so mad with the hotel manager because he refused to refund my booking fee. The entity is the hotel. The aspect is the manager. It's part of the hotel. Motion type is anger. The feeler is I, and the time is unknown. This definition can also include the cause. So emotional expressions can use emotion or mood words or phrases. For example, love, disgust, angry, and upset. They can describe emotion-related behaviors. They can use intensifiers, which some common English intensifiers include very, so, extremely, dreadfully, really, awfully, etc. They can use superlatives. Many superlative expressions also express emotions. This car is simply the best. They can also use pejorative, laudatory, and sarcastic expressions. They can also use swearing, cursing, insulting, blaming, accusing, and also threatening expressions. Now let's take a look at document sentiment classification. So, to classify a whole opinion document, you have to take the overall sentiment of the opinion holder, and it can be broken down into the 3 classes: positive, negative, and possibly neutral. The example they bring here is, I bought an iPhone a few days ago. It is such a nice phone, although a little large. The touchscreen is cool. Voice quality is great too. I simply love it. So the classification be positive or negative. So it's basically a text classification problem. However, there's an assumption. The document is assumed to be written by a single person and express an opinion or sentiment on a single entity. Reviews usually satisfy the assumption. Almost all research papers use reviews, and with the star system, 4 or 5 stars are considered positive, 1 or 2 stars would be considered negative. Forum postings and blogs do not. They may mention and compare multiple entities, and many such postings express no sentiments. Supervised learning techniques have been directly applied to classify reviews into positive and negative. 3 classification techniques have been tried. There's naive Bayes, maximum entropy, and support vector machines. Negation tag, unigram, bigram, part of speech tag, and position are all used as classification features. SVM did the best based on movie reviews. The problem has been studied by numerous researchers, and a large set of features have been tried by researchers. Terms and their frequency. These features are individual words or word n-grams and their frequency counts. Parts of speech tag, which research has shown. Adjectives are important indicators of opinions. Opinion words and phrases, negation, and syntactic dependency states that words, dependency-based features generated from parsing or dependency trees are also tried by several researchers. There's also a lexicon-based approach where you use a set of sentiment terms called the sentiment lexicon with positive words and negative words, and then you give them semantic opinion orientation value for each term. You can give it to them between -5 and a +5, and considering use an intensifier like very or a diminisher like barely, you can decide on their scores, and from the aggregated scores, you figure out their total sentiment view. There's also deep learning. Recently, deep neural networks have been used for sentiment classification. Socher and his team used deep learning to work on the sentence parse tree based on words, phrases, compositionality in the framework of distributional semantics. Many papers. Review rating prediction. Apart from classification of positive or negative sentiments, research has also been done to predict the rating scores of reviews. Sometimes, for example, 1 to 5 stars. The problem is formulated as a regression since the rating scores are ordinal. Now, sentence subjectivity and sentiment classification. Usually consists of 2 steps. Subjectivity classification to identify the subjective sentences, and sentiment classification of the subjective sentences, which puts 2 classes, positive and negative. But also, again, bear in mind, many objective sentences can imply sentiments, and many subjective sentences do not express positive or negative sentiments or opinions. The example they give here is, I believe he went home yesterday, which isn't positive nor negative. Again, the assumption that each sentence is written by a single person expresses a single positive or negative opinion or sentiment. True for simple sentences, like I like this car, but not true for many compound and complex sentences. I like the picture quality, but battery life sucks. Apple is doing very well in this poor economy. To identify a subjective sentence, a few methods have been tried. There's been sentence similarity, Also, naive Bayesian classification, which uses probability. And for sentiment classification, positive, negative, or neutral, they use a method of seed words, and based on its log likelihood ratio, it takes the average log likelihood ratio score of each of the words in the sentence, and it uses cutoffs to decide whether it's positive, negative, or neutral. Now, if it since a single sentence may contain multiple opinions and subjective and factual clauses, which means it violates the assumption, a study of automatic clause sentiment classification was presented to classify clauses of every sentence by the strength of the opinions being expressed in individual clauses. And that was brought down to 4 levels: neutral, low, medium, and high. However, the clause level may not be sufficient. For example, Apple is doing very well in this lousy economy. Again, numerous papers have been published on using supervised machine learning. The deep neural networks have been used. Many more papers. All right, so the next thing we're talking about is the aspect-based sentiment analysis. So up until now, we're just trying to determine whether an opinion is positive or negative. So we may need to go further. And sentiment classification at both the document and sentence or clause level are useful, but they do not find what people liked or disliked. They don't identify the targets of opinions, the entities and their aspects. And without knowing targets, opinions are of limited use. We need to go to the entity and aspect level. So thus, we need the full opinion definition. So if you recall, opinion is a quintuple: the entity, aspect, sentiment, holder, and time. For aspect-based sentiment analysis. So our goal for the aspect in opinion corpus is to extract all the aspects, and there's 4 main approaches: finding frequent nouns and noun phrases, exploiting opinion and target relations, supervised learning, and topic modeling. Nouns that are frequently mentioned are likely to be true aspects, frequent aspects. Why? Because most aspects are nouns or noun phrases. When product aspects or features are discussed, the words I use often converge, and those frequent ones are usually the main aspects that people are interested in. So by removing some of the frequent noun phrases that may not be aspects, they were able to improve this. It identifies part of a relationship. Each noun phrase is given a point-wise mutual information score between the phrase and part discriminators associated with the product class. In this case, it's scanner class. So what they did was by searching the web for the point-wise mutual information, they took how many hits they received on A and D together, and they divided it by how many hits A and D had when they were statistically independent. You can also extract aspects by exploiting opinion and target relations. The key idea here is opinions have targets. Opinion terms are used to modify aspects and entities. So the pictures are absolutely amazing. And this is amazing software. The syntactic relation is approximated with the nearest noun phrases to the opinion word. The idea is generalized to syntactic dependency and double propagation. And double propagation, it's based on a definition earlier. An opinion should have a target entity or aspect. It uses dependency of opinions and aspects to extract both aspects and opinion words. Knowing one helps find the others. The example here is the rooms are spacious. It extracts both aspects and opinion words, and it's a domain independent method. Double propagation is a bootstrapping method. With the input is a set of seed opinion words. However, no aspect seeds are needed, and it's based on a dependency grammar. And here they've got a tree. Denotes this phone has a good screen. You see here, these are rules of dependency grammar. And here is the double propagation method again, where it has a seed list of opinion words and phrases, and then you extract new targets from the opinion words, find other instances of new targets, extract new subjective modifiers of new targets, and find other instances of new modifiers, which brings you back to extracting new targets from the opinion words. So instead of manually deciding a fixed set of dependency rules and relations as in double propagation, another paper proposed to select rules automatically based on rule induction. The input has all dependency relation / rules. The system selects an optimal subset, and the selected rule subset performs extraction significantly better. Some rules in double propagation are actually not selected. So an opinion relation has three components. There's a correct opinion word, the correct opinion target, and linking relation between them. And this paper proposed a deep learning approach to identify. Due to the problem of obtaining negative training data, it applied the idea of one-class classification and a final network, one-class deep neural network. So there's explicit aspects and implicit ones. See, aspects explicitly mentioned as nouns or noun phrases in a sentence. Implicit aspects are aspects not explicitly mentioned in a sentence but are implied. And some work has been done using supervised learning, using sequence labeling methods such as hidden Markov models, conditional random fields, and other supervised or partially supervised learning. Also, you can identify aspect synonyms. Once aspect expressions are discovered, you can group them into aspect categories. The example they use here are power usage and battery life are the same. The method is based on some similarity metrics, but it needs a taxonomy of aspects. For the mapping, the system maps each discovery aspect to an aspect node in the taxonomy. Similarity metrics, string similarity, synonyms, and other distances measured using WordNet. So after the aspect synonyms have been identified, unsupervised learning can be used in the form of clustering and constrained topic modeling to group the synonyms. A variety of information or similarities are used to cluster aspect expressions into aspect categories. Lexical similarity based on WordNet, distributional information, and syntactical constraints. Here we got a couple of some formulas for WordNet similarity and for expectation maximization based probabilistic clustering. For topic modeling, aspect extraction has two tasks. First one being extract the aspect expression. The second one is to cluster them. For example, picture, photo, or image. Top models are PLSA and LDA, perform both tasks at the same time. Topic is basically an aspect. A document is a distribution over topics. Topic is a distribution over terms and words. For example, price, cost, cheap, and expensive all denote the same topic. Let's see, there's other many other related models and papers. They use topic models to model aspects, jointly model both aspects and sentiments. Unsupervised models are often insufficient because of this. Knowledge-based topic models have been proposed, guided by user-specified prior domain knowledge. They use C terms or constraints. So for aspect sentiment classification, for each aspect, you must identify the sentiment about it. Work based on sentences, but you also have to consider that a sentence can have multiple aspects with different opinions. The battery life and picture quality are great, but the viewfinder is small. So you've got a couple of positive aspects and a negative one. Almost all approaches make use of opinion words and phrases. You have to also keep in mind some opinion words have context and independent orientations. For example, good and bad are generally universal for meaning positive or negative. However, some other words have context dependent orientations. They use sucks as an example here, which would be terrible for everything other than a vacuum cleaner. So to continue aspect sentiment classification, there's the lexicon-based approach, which uses parsing. It says here that supervised learning is tricky, which feature weighting considers distance between the word and the target entity / aspect, and also use a parse tree to generate a set of target-dependent features. So for the lexicon-based method, the input is a set of opinion words and phrases, a pair, AS, where A is an aspect, and S is a sentence that contains A. And output, whether the opinion on A in S, the aspect in the sentence, is positive or negative, or neutral. So you do this in two steps. The first step is to split the sentence, if needed, based on but words, like but, except that, etc. And then the second step, work on the segment, sentence fragment containing A. Let the set of opinion words in the sentence fragment be word 1 through word N. Sum up their orientations, either 1, -1, or 0, and assign the orientation to AS based on the summation of the opinion orientation and the distance from A to W1. So then we have sentiment shifters, which are also called balance shifters, the words or phrases that can shift or change opinion orientations. Negation words like not, never, cannot, etc. are the most common type. Many other words or phrases can also alter opinion orientations. Would, modal auxiliary verbs such as would, should, could, etc. For example, the break could be improved is denoted as being negative, and it's also it's very complicated. sentiment shifters continued, some presuppositional items can change opinions too. For example, barely or hardly. So if you were to say it works, it's a lot different than saying it hardly or barely works. It presupposes that better was expected. Words like fail, omit, neglect behave similarly. This camera fails to impress me. Sarcasm changes orientation too. What a great car. It did not start the first day. And some rules were designed based on parsing the fine scope of negation. So opinions and sentiments are governed by many rules. P is defined by a positive opinion, word, or phrase. N is defined by a negative opinion, word, or phrase. See, that's for opinion, word, or phrase. There's desirable or undesirable facts. For example, after my wife and I slept on it for 2 weeks, I noticed a mountain in the middle of a mattress. So P is defined by a desirable fact, and N is defined by an undesirable fact. Basic rules of opinions. High, low, increased and decreased quantity of a positive or negative potential item. For example, the battery life is long. PO is defined as no low, less, or decreased quantity of NPI, or large, larger, or increased quantity of PPI. NE is defined as no low, less, or decreased quantity of PPI, or large, larger, or increased quantity of NPI. Where NPI is defined as a negative potential item, PPI as a positive potential item. So essentially, you're making if you make a positive potential item large, larger, or increased, you're making it positive. And if you're decreasing a negative potential item, you're also making it positive, and vice versa for the negative aspect. This continues by saying decrease and increased quantity of an opinionated item. This drug reduced my pain significantly, and a deviation from a desired value range. This drug increased my blood pressure, this drug increased my blood pressure to 200. So because it wasn't in the desired value range, it was denoted as being negative. Producing and consuming resources and waste can create an opinion of a positive opinion or a negative opinion. This washer uses a lot of water. That would be construed as being negative. If it used less water, it would be seen as being positive. So next we talk about mining comparative opinions. So comparative opinions are going to involve two entities or aspects, and there's gradable, which are divided into non-equal gradable, which is relations of the type greater or less than. For example, the sound of phone A is better than that of phone B. Equative, relations of the type equal to. So camera A and camera B both come in 7p, they're both equal. And superlative, relations of the type greater or less than all others. Camera A is the cheapest in market. So the objective is given an opinionated document D, extract comparative opinions. And that's broken down to E1, E2, A, PO, H, and T. Where E1 and E2 are the entity sets being compared. A is their shared aspects. PO is a preferred entity. H is the holder, and T is the time. No, this doesn't involve positive or negative opinions. So for example, consider the comparative sentence, Canon's optics are better than those of Sony and Nikon. It's written by John in 2010. The extracted comparative opinion / relation are shown here. Canon would be the first one, and first entity. Sony and Nikon are both considered the second one. Optics are the shared aspect. It's preferred by Canon, for Canon, and John is the holder, and 2010 is the time. So in English, comparatives are usually formed by adding ER, and superlatives are formed by adding EST to their base adjectives and adverbs. Adjectives and adverbs with 2 syllables are more or more, and not ending with Y, do not form comparatives or superlatives by adding ER or EST. Instead, more, most, less, and least are used before such words. For example, more beautiful. You wouldn't be able to say beautifulest or beautifuler. Irregular comparatives and superlatives use more, most, less, least, better, best, worst, worse or worst. So you first have to identify comparative sentences, which is done by supervised learning, and then you gotta extract the different items, which you can use label sequential rules or conditional random fields, and then determine preferred entities or opinions. Use the lexicon-based methods, parsing and opinion lexicon. Gradable comparative sentences can be dealt with almost as normal opinion sentences. For example, optics of camera A is better than that of camera B. Camera A optics are positive, camera B optics are negative. You run into difficulty, though, when you try to recognize non-standard comparatives. In the example sentence here, I am so happy because my new iPhone is nothing like my old, slow, ugly Droid. It's tough to decipher with the wording of that sentence. In identifying preferred entities, the following rules can be applied. A comparative negative is defined by increasing comparative negative or decreasing comparative positive. Comparative positive is defined by increasing comparative positive or decreasing comparative negative. Example is Coke tastes better than Pepsi. So Coke is comparative positive because it's tastes better than Pepsi. Or Nokia phone's battery life is longer than Moto phone. Context-dependent comparative opinion words. Using context pair, the aspect and the adjective, or the adjective comparative, or deciding the polarity in a corpus based on its context. Battery life and longer. Longer for battery life is good. Longer for wait times in a line is bad. So then we'll go on to talk about opinion lexicon generation. Sentiment lexicon is a list of words or expressions used to express people's subjective feelings and sentiments or opinions. Not just individual words, but also phrases and idioms. And they are instrumental for sentiment analysis. There seems to be endless variety of sentiment-bearing expressions. There's been 6,700 individual words, more than 6,700 individual words compiled, and there's also a large number of phrases. Sentiment words or phrases, also called polar words, opinion-bearing words, etc. Positive ones are beautiful, wonderful, good, amazing. Negative are bad, poor, terrible, cost an arm and a leg. Many of them are context dependent, not just application domain dependent. Three main ways to compile such lists is a manual approach, which isn't necessarily a bad idea, only a one-time effort. However, it takes a lot of time, or the corpus-based approach and dictionary-based approach. The corpus-based approaches rely on word patterns from a large body of work and can find domain-dependent orientations. Let's see here. Sentiment, consistency, use conventions on connectives to identify opinion words. They use conjunctions, which conjoined adjectives usually have the same orientation. For example, the car is beautiful and spacious, and or but, either or, neither nor have similar constraints. There's learning using log linear model, which determines if two conjoined adjectives are of the same or different orientations, and also clustering, which produce two sets of words based on their polarity, whether they're positive or negative. Opinion orientation is sometimes context dependent. Just by finding the opinion words in a domain is insufficient. A word may indicate different opinions in the same domain. For example, the battery life is long is a positive statement, and it takes a long time to focus is a negative one. Sentiment consistency, both inter and intra-sentence, can be exploited based on context, and it assigns an opinion orientation to the pair. The same double propagation method can also use dependency of opinions and aspects to extract new opinion words. Based on dependency relations, knowing an aspect can find the opinion word that modifies it. For example, the rooms are spacious. Knowing the opinion word can find more opinion words. The rooms are spacious and beautiful. Most opinion words are subjective words. For example, good, bad, hate, love, and crap. But objective nouns can imply opinions too. For example, after sleeping on the mattress for 1 month, a valley or body impression has formed in the middle. Resource usage descriptions may also imply opinions, as mentioned in the rules of opinions. For example, this washer uses a lot of water. For the dictionary-based methods, it typically uses WordNet synsets and hierarchies to acquire opinion words. It starts with a small seed set of opinion words, and then it bootstraps a set by searching for synonyms and antonyms in WordNet iteratively. Semi-supervised learning. Using supervised learning, given two seed sets, positive set P, negative set N, the two seed sets are then expanded using synonym and anonym relations in an online dictionary, generate the expanded sets P and N. P prime and N prime form the training sets, using all the glosses in the dictionary for each term, and P prime cup N prime, and converting them into a vector. Build the binary classifier. So which approach to use? Both corpus and dictionary-based approaches are needed. A dictionary usually does not give domain or context-dependent meaning. Corpus is needed for that, and corpus-based approach is hard. It's hard to find a very large subset of opinion words. Dictionary is good for that. In practice, all three of them of these approaches are needed. So some interesting sentences. These are the ones that the computer will have a hard time designating. Try out Chrome because Firefox keeps crashing. We need to segment the sentence into clauses to decide that crashing only applies to Firefox. But what about these? I changed to Audi because BMW is so expensive. I'm so happy that my iPhone is nothing like my old ugly Droid. See, the following two sentences are from reviews in the paint domain. For paint X, one coat can cover the wood color. For paint Y, we need 3 coats to cover the wood color. We know that paint X is good and paint Y is not, but how? By a system. Conditional sentences are hard to deal with. questions are also hard to handle. There's also sarcastic sentences you've got to deal with. Sarcastic sentences are common in political blogs, comments, and discussions. Opinion mining is hard. This past Saturday, I bought a Nokia phone, and my girlfriend bought a Motorola phone with Bluetooth. We called each other when we got home. The voice on my phone is not so clear, worse than my previous Samsung phone. Battery life is short too. My girlfriend was quite happy with her phone. I wanted a phone with good sound quality. So my purchase was a real disappointment. I returned the phone yesterday. And finally, the summary. The chapter presented problem with sentiment analysis, main research directions and their representative techniques. Still many problems not attempted or studied, and none of the sub-problems have been solved. It's a fascinating natural language processing or text mining problem. Despite the challenges, applications are flourishing, and the general natural language understanding is probably too hard, but can we solve this highly restricted problem? We should have a good chance.